Hello, and welcome to this little demonstration of a utility AI, okay, by me and two others, Matthias and Oliver. This is a mini project for an AI course at Aalborg University, and we've decided, or been given the task of creating a utility AI, preferably using the Apex utility AI tool, which we have. And in this, just briefly, utility AI is a score qualifier dependent AI, at least the way Apex does it, where the behavior of an entity, an AI entity, is determined by qualifiers and scores, and then certain rules for that. For example, the higher score wins, or so on. And just a little example of this would be the HIDA AI that we have, where it has a standard behavior, which has a lower score and not any scorer for sneak, because it should always fall back to that. Sneak will make the hider move from its current position, using the nav mesh and avoiding all obstacles there, to the goal. If, though, that it comes upon a seeker that spots it, you can see the qualifier or scorer is spotted. That means it looks at its own context and see, have I been spotted? Then, oh yes, this is a high score, so it needs to flee. Which in our case means that it will try to put an obstacle between itself and a seeker to get out of the line of sight. When it has done that, it will return back to sneak. But of course, flee just brings it to the obstacle, and then it hides for a while this score trickles down until it gets below its default behavior. So when it thinks that it has hidden for enough time, it will then return back to its default behavior. And of course, this hide is determined by the should hide scorer. The seeker, on the other hand, also contains, of course, scorers and behaviors. Its default behavior is to patrol, and you can see here, if I bring up one of the patrol paths, this particular seeker will go from point to point, forward and back, until it forever, actually, since it's the default behavior. It will stop from this behavior, though, at the highest priority of chase. It's a very high score, which means that it has seen a hider, and it will try to chase it down and catch it. If it's unsuccessful and the hider succeeds in hiding behind an obstacle, it looks at the score, is investigating, which trickles down for a long time, and this behavior simply looks at the last place it saw the hider and will investigate in a random position inside a radius. And when it thinks it has done that long enough, or when the score has trickled down enough, it will return back to its default behavior. And of course, this whole game is just a simulation to see how utility AI could be used. But in order to facilitate all these behaviors, you normally talk about using perception. And in our case, they all have a scan script on them. So, for example, the hider can see in a sphere around it. So it's more of a listen than a see. So it will look at the closest obstacles, it'll look at the closest seekers, and then, if it gets spotted, it will go to its closest obstacle and try to put it behind, between the seeker and the hider. The seeker has a sort of cone structure, which is cast by rays, and it will look around and only see in that cone in front of it. I think it's a 45-degree radius. And if a ray hits there and it's a hider, it will go towards the hider. The chase will trigger, except if that ray has passed through an obstacle, which obviously it cannot really see it even though the ray hits it. So these are kind of the perception possibilities that are given to the seeker and the hiders. And I think we should see like a little demonstration of how it is in play, and then I'll show you the debug mode. So the hider starts moving towards its goal. Oh, it has been spotted. It's trying to put a... Oh, and it evaded the seeker there for a moment. And it reached its goal. It escaped. Of course, in order to see more under the hood, we have also implemented some sort of debug visualization. Fair warning, it runs very slow because it makes a lot of checks. But just to show how it's going, you can see the radius of this. You can see the red is when it has spotted it. Blue is within this radius, and red is when there's an obstacle between it. So blue has found its target and can see it. So, and sometimes, as AI always does, it freaks out a bit. This, of course, is not so interesting on such a small scale, which of course is why we thought we would bring it to a large scale. Alright, just had to make the scene set up as it shares the terrain. But in any case, it uses nav mesh. Just make it to see. It uses nav mesh to determine obstacles, and all the entities are nav mesh agents, so it makes sure they avoid each other and don't bump into each other, even though they try to sometimes. But that's the wonder of simulation. But I think it would be interesting to show, as I said before, this project on a larger scale. So I won't turn the debug on. Maybe actually, I'll show you afterwards. But this is how it looks on a big scale, with some 10 seekers. Some of them are being caught, I can see. Some of them are trying to hide, in groups even. And it seems like... Oof, so close. Well, it seems a few of them will escape. We can see. So that is how it works on a big scale, and in general it could be scaled up to anything as long as all the patrol paths are being made, just to see kind of the chaotic nature of this kind of system. Yeah, many patrol paths. So that is our little demonstration. Hope you enjoyed it.